And I remember going and watching apprentices learn how to machine and thinking, this is crazy. They're being started on handwriting G code with a pencil for weeks before they're then allowed to put it into a machine. Actually, and before even that, they've been doing manual machining to get a feel for the metal. Like, fine, I got a feel for the metal. I don't think that has ever helped me in CNC machining. It's not completely unnecessary. And if you have, say, 100 hours to train someone, would you rather that was being started already at the highest level of the automation and then learning more complex things afterwards? Or would you rather they started learning how to write G code with a pencil? Like, I know which training program I would rather do. I know which would make the more useful person into the market. So yeah, I think that people should be starting on CAM software with CNC machines, with CAM Assist, and then learning how to fill in the blanks.
Hey, everybody. Welcome to ShopTalk, the podcast series where we talk to makers, inventors, designers, and engineers from shop to shop. And today we're talking to Theo Saville from CloudNC. This is a guy who was in engineering school, kicking around in the CNC shop and finding frustrations everywhere that he wanted to solve. He then turned that into an amazing company with an amazing product. So stick around. This is a good story. All right. Theo Saville, CEO and co-founder of CloudNC. Thanks for coming, man.
Oh, my pleasure. It's great to be here.
Why don't you tell us about your background? Let's start there. How did you get started in this stuff?
Sure. So my background's manufacturing and mechanical engineering, and I always loved making things when I was younger. You'd always find me in the lab. Wherever there was a lab, I was in it. If there wasn't one, I was looking for one. I was, using the first 3D printers as they came onto the market. I learned how to use a lathe when I must have been 12. I've been making things for a really, really long time. And like CloudNC really came around from frustration that I could make anything I wanted in plastic. I had 3D printers, could make any geometry. But as soon as I wanted to go to metal, as I had to for the really complex projects that I was doing at college, like building a racing submarine to go race in the States, the lead times through the workshop were 10 weeks and no one would let me use the equipment. And I just wasn't used to that. I'm not used to someone telling me you're not allowed to use that machine and you don't know how to use it either. And I tried to use them anyway, and I couldn't figure it out. And I'd never stood in front of a machine that I couldn't work out before without training. And this really shocked me. It surprised me. And that idea kind of developed over the course of a couple of years, and I left college and I was wondering what to do with my life. I was kind of around the San Francisco area, and so being infused with startup vibes, and the idea just came, why don't we try and make that machine a bit more automatic? How hard can it possibly be? Famous last words.
Well, I mean, you make it look easy. I got to say,
It was not. It was not easy.
Well, tell us a little bit about that then. I mean, you're not a software guy, right? Or at least you weren't when you started. You're a maker and a mechanical engineer and all that. I'm guessing your co-founder maybe is the software guy.
Yeah, exactly. My background was really manufacturing engineering. I've really just been in the business of making things and business. I started my first little company when I was 15, building and selling gaming PCs on eBay. I probably built 30, 40, maybe 45 of them over a year and a half. And then I started another little business before I went to college, and this was number 3. So for me, it's always been about making stuff and business. And ultimately, building a business is still building. I would have loved to have known how to use software, but I don't think I started early enough. And nothing I ever wanted to build was a piece of technology. I'd always sit in front of the computer going, what do I actually want to build on this computer? And I couldn't come up with an answer. But, build a little steam engine. Great. I could do that all day long.
Yeah, yeah. I think you've got a lot in common with a lot of the people that watch this podcast, myself included. And I think it's an inspiring story because we do this all the time, right? People who make things are constantly working on a project. You're making some work holding thing, or you're making a jig for something, or you're finding a way to kind of solve a problem that's a practical thing. And then I think most people, even if they have a really good idea, they kind of stop there and think, oh, well, I don't know anything about programming. So, wouldn't it be cool if, right, there was this product you could use where you just click a button and it gives you all your tool paths in one place.
That was kind of what I was expecting. Actually, no, that's not true. I wasn't expecting it to give me all the toolpaths. The first CAM software I ever tried to use was AlphaCam, but I was expecting it to give me feeds and speeds.
Uh-huh.
That was what I was expecting. It didn't do that. It didn't even come close to that. And that was the first hint of there being, like a problem. It's like, hey, I've got a material, I've got a geometry of pocket, I've got a tool, I've got some like parameters from the manufacturer. The middle bit's just math.
Yeah.
Why isn't this automatic? That was where it began.
Yeah. There's a sixth grade level algebra equation to solve this problem. Why do I have to do this myself every single time?
Exactly.
We've
And
all been
the
there.
other key moment was I had a component that I needed to make. It strapped a gearbox to basically some bicycle pedals and turned the entire motion 90 degrees. And I'd drawn it up in CAD. It was 2D. It was fairly simple. I took it to the workshop and said, like, can you make this? And they said, no, come back with a drawing. So I did. I came back with DXF because, what else would I come back with? And they said, no, a paper drawing. And so fine, I'll come back with a paper drawing, and I threw some tolerances on it, just kind of for the hell of it.
Yeah.
There didn't need to be a tolerance component at all. And I then watched the machinist. I was very fond of this guy. He taught me quite a lot, but I watched him redraw my 2D drawing back into DXF on his computer. And I made him then go and look at mine. And I was like, he said, oh, it's probably full of holes. I said, there are no holes in this. Like the diagram is perfect. We just spent half an hour doing this for no reason. He admitted, yeah, fine, your drawing was fine. You could have used it in the first place. And that was like the second what the hell moment, but on, a series of what the hell moments that led to the idea.
I've been there so many times. I mean, all through the years, through college, and then like I worked in the I did special effects and animatronics in the film industry, and that you just described pretty much everything that ever happened there. It's like if I wasn't running the machine myself, there was somebody else, and it was like, yes, here is a document with some information on it for you, even though I can just draw this thing up and give it to you. So I mean
Yeah.
that brings us to the whole idea of well, probably there's your name, right? CloudNC. So everything is connected on the cloud, being part of that idea, right?
Yeah, it wasn't. It was dumber than that. It
Yeah.
was more like we were given 20 minutes to come up with a name at our startup accelerator because they said you're going to change it anyway. Never did. And so I was like, CNC, CNC. Well, we're going to do AI in CNC. And we'll need the cloud because that's the only place that's going to be powerful enough to run the AI. So I guess we'll make it cloud numerical control machines, Cloud NC. Thing. Never changed it.
Nice. And who were your first customers? I mean, how do you even start something like this?
Mm,
How do you start
yeah.
selling it? Like I don't want to get too much into the business side of things. Like maybe that's not that interesting to the audience, but I'm just curious. Like how do you go from like, okay, you've got an idea, you've got a partner, there's an incubator, how do you get people using this thing?
Well, this is actually quite interesting because the first person who paid to use CloudNC Canvas, so our software, uh, they didn't pay for it until maybe 8.5 years after we started the company.
Uh-huh.
And that journey in the middle is very interesting. So the first paying customer we had wasn't for software, it was for components. Like I remember that job. I remember it very well. My co-founder made it on our HAS that we had in a little shed. And then the second, it was like $1,500 that we won off like a Xometry competitor.
Yeah.
And then I won the next one, which was 15 grand. And we spent a while trying to make all of these tiny little, very simple parts. And it wasn't for a very long time before we were able to sell software. Like,
Wow.
it took that long to build software that actually worked. It's too hard.
So you did it, you were your own customer for 8.5 years.
So I'd say for the first maybe 4 years,
Uh-huh.
the technology could not do anything useful at all. Like we could demo, and it looked like something that would almost work, maybe soon.
Yeah.
And it looked like it was going to almost work, maybe in the next year or two for another 4 years. And then eventually it just did. And it wasn't very good at year 8.5. I, apologized to that very first customer because, we gave them something that was really quite trashy. But you should always be embarrassed by the first product you release. And over the last year and a half, it's become more and more and more effective to the point now where it is really very effective. And we're quite proud of what we sell. But no, like the first version that we shipped, that had some real bugs.
Yeah. That's so interesting though. So you were able to sustain yourself by actually producing parts. And then at the same time, that's how you're learning to make this actually work the way it needs to work for a real customer because you're seeing it there real time yourself. That's a new
Yeah,
one
and
for me. I'm not familiar with any other companies that have done it that way. Is this like a normal thing I'm just not aware of?
no, it's a really unusual journey.
Yeah.
The like the way that you normally build a company of any kind is, you start and you sell and you know support yourself off your revenues. Or if it's
Yeah.
a startup and you need time to develop, then maybe you have a year, tops two, of development before you're in market selling a product. And that is enough to then go and raise money, to then make more revenue, to raise more money. And then eventually one day you become profitable. Whereas this, it falls into the category of deep tech, where it takes, up to a decade in order
Yeah.
for the product to be complete, a bit more like a farmer journey, for example.
Yeah.
And that is a very bruising and difficult journey. It's a path not very often trodden, and there are not that many investors who are willing to back it. So it's hard.
I mean, I'm picturing all these times you were just so ready to throw in the towel. Like, this
Yeah.
is not working. Like, do I really want to do this for another 5 years before this thing might get to the place where it's going to be? What kept you going? Like, what kept you pursuing this goal?
Yeah, there was only one time that I wasn't ready to throw in the towel, but I was legitimately worried that it wasn't going to work. And that was probably year 7.5 to 8. At that point, it was just beginning to work, but it had been not working for so long that I was honestly starting to lose faith. Before then, I just had unshakable, invincible faith. And I think that came across to our various backers, and the technology was always just close enough to look like it was almost ready to work. Until then, eventually it did.
Yeah.
It would have been a much easier journey if it had worked maybe a year sooner than it did. But
Yeah.
no, like you, in order to go on this journey, one of the things that you need is unshakable faith that what you're doing is right and that it
Yeah.
will work if you go for long enough.
Yeah. Yeah. I mean, unshakable faith in what this thing could be is, I
Yeah.
totally understand that. Like the goal from the like you're picturing in your head, if I can get a machinist to just push one button and get him 80% there with an entire, set of tool paths to make a part, like that is solid gold, right?
Everyone agrees
Obviously.
that was valuable, and that
Yeah.
really helped. If it was like maybe it will be useful or not, then that's a lot
No.
harder to hold faith over. But this was only holding faith over one side of the equation. If they
Yeah.
buy it, if we build it, they'll definitely come. Can we build it?
Yeah, yeah. It's no, it's like the holy grail, man. It's using CloudNC last week, just like trying it out. I couldn't believe it. Like this is what we've all been like hoping for, and it's really there now. It's amazing.
Glad
It's
you like
for
it.
yeah, it's really cool, man. It's really cool. It's what the thing is, it gets me excited about like, these I got these little ideas floating around. Like, oh, I'd like to make that thing and like this like cool bracket for a piece of furniture or something like that. And I've got access to the machines, right? But now it's like, oh, I don't actually have to sit there for an hour and like kick around with the, making the tool paths myself and troubleshooting all that stuff. Like I can just click a button and I'm almost there at that point. Um, yeah, it's for people that aren't, if you're not totally familiar with this world, I think I kind of summed it up there. So the way this typically works is you've got a CAD model, and then you get into your CAM environment. In Fusion, it's in the same product, right? You go in there, and then you go through the steps of machining a whole part. You start with a piece of stock. It's like a rectangular solid, a piece of aluminum or whatever it is. You start going through your operations in a way that makes sense to you. I'm going to face it down first on the top. Then I'll do like maybe there's an outline toolpath around that, a profile. I'll get the flats after that. There's holes, right? Like you sort of go down the order of operations, taking away more and more material. But you have to make all the decisions yourself along the way. You have to pick the tools and all that, right? But with CloudNC, with Cam Assist, you push the button and then you basically give it your tool library, and there's a few other parameters in there you set, and then it's just there's all your tool paths. So I mean, do you think I described it more or
I think
less?
you
What?
absolutely nailed it. Yeah,
Yeah,
that's it.
yeah, and it's crazy because like I don't know. It's still I'm still kind of trying to get my head around the implications of it, right? Because learning to be a machinist, like getting trained on these machines, this one, I mean, it's a Tormach. It's not this isn't anything super complicated, but like when I was at our technology center in San Francisco, I learned to use we have a big Haas there. There's we had a Moriseki for a while. There's Matsura. Like there's some machines they're very complicated, right? Like the stakes are high to get this stuff right. Um, you really don't want to be the guy that breaks a tool, right? Is if you've got access to a machine like this, crashing something into a a piece of work holding, a vise or whatever it is, like there's a lot that can go wrong here. So while you're learning to do it, it's a really big time investment to get through all this stuff, and it just makes me wonder, so getting to the AI side of things, right? You're going from somebody being able to do that, right? Getting a whole list of tool paths ready to go, all your setups ready to go, all that stuff. Getting that done based on crystallized knowledge and a lot of years of experience, right? You're going from that to somebody getting you almost all the way there uh, after, I don't know, like maybe a semester of a machinist program or something like that. Is that do you think that's feasible?
I think so. And I remember going and watching apprentices learn how to machine and thinking, this is crazy. They're being started on handwriting G code with a pencil for weeks before, they're then allowed to put it into a machine.
Wow.
Actually, and before even that, they've been doing manual machining to get a
Right.
feel for the metal. Like, fine, I got a feel for the metal. I don't think that has ever helped me in CNC
Yeah.
machining. It's not completely unnecessary. And if you have, say, 100 hours to train someone, would you rather that was being started already at the highest level of the automation and then learning more complex things afterwards? Or would you rather they started learning how to write G code with a pencil? Like, I know which training program I would rather do. I know which would make the more useful person into the market. So, yeah, I think that people should be starting on CAM software with CNC machines, with CAM Assist, and then learning how to fill in the blanks. It's a
Yeah.
lot easier to fill in the blanks of something that's already done than to just be sat down as a student in front of a blank screen and be told, all right, go and lay down some toolpaths. No, I'd rather pattern match backwards. I'd rather duplicate things that work and troubleshoot services that aren't done. That's much, much easier.
The one thing that's given me pause is, what about the intern, right? Like, what about this young person that comes in that doesn't have experience in this environment? That's normally the person you put on, like, do this kind of menial thing for a couple years, right? And then after
Mm.
you've done that menial thing for a while that I don't feel like doing, um, you know, we'll give you something more interesting later. But what you're telling me is there's this other option, which is get them set up with,
Mm.
with these AI tools first. Like if that's what they learn when they're in school, and then they bring that stuff to the workplace. Now they're like way more valuable than they would have been as just a
Yeah.
normal intern, right? So
Yeah.
it's a leg up for people coming in now, way more so than it is an encumbrance, right?
Yeah, like if you have, I know people who entered the trade, call it like 10 or 15 years ago, and their learning trajectory is like that, and they have to, speak to someone or get someone to train them every time they need to learn. And then, the intern comes in who is au fait with ChatGPT and goes there for everything first and is using AI tools, then their trajectory is going to be like that,
Yeah.
and they're going to overtake fairly quickly. And the last conference I was at, I like very strongly encouraged everybody to kind of adopt those tools and adopt those mindsets just so they can increase their pace of learning. Like if I'd had ChatGPT when I started my factory, I think it would have been a lot more successful, a lot faster, because we would have had access to this knowledge base that otherwise we would have had to like speak to consultants and hire people for, and like really struggle and experiment through. And that knowledge is all there. It's just it used to be way too distributed. Now it's easily available.
Yeah. When I think about what you're doing with Cam Assist, with CloudNC in general, what you're doing, let's go with the Softjaw designer, for example, right? That's a really cool feature, right? If you're not familiar, Softjaws are basically they're a vise for that conform to the shape of a part that's already been cut in some way. So you mill one side of a part from a rectangular solid, and then when you flip it over, you've got to get that other side off. Now you've got this odd shape, right, that needs to be clamped onto something. So soft jaws are a vise that has the outline of the profile of that shape that is needed to hold it together, right? So that is a tedious task that basically consists of you going back into CAD, flipping your part over, or whatever, flipping your perspective, putting the jaws around it, go into sketch mode, project your profiles. Like you're doing all this stuff yourself to make something that is actually pretty simple. There's not that was kind of a waste of your time when you think about it, because there's a shape there that needs to be cut out of another shape. It's not a complicated thing. It's not something that like really, it's not a good use of your time or your attention, right? Um, so, and I think a lot of that's kind of what it comes down to with CAM in a lot of ways. Now that I think about it, you're not really doing that. That stuff you're doing is not very complicated. You've got a mill that's cutting stuff out, or you've got a lathe that's cutting uh, chips off of a piece of metal, right? So like, there's geometry around it. The things that are happening there are pretty straightforward. So I don't know. Now that I think about it, it's a great candidate for an AI solution, right?
Yeah, yeah. The soft drawers was honestly not that hard to build. Yeah, it's you're doing a Boolean subtraction, and the jaws mustn't interlock with the component, and there's not a lot more to it than that.
Yeah.
But if you draw them by hand, it takes 40 minutes to an hour every single time.
Yeah.
What a waste of time! Why did nobody build this? It wasn't that hard.
Yeah.
It
I mean,
really wasn't.
yeah, man. Yeah. Cause you can add, I haven't actually used it, but I'm guessing you can add like, tolerances, right? So like,
Yeah,
you're not going to get
you
like
get
a
corner
one.
reliefs. Yeah, you get corner reliefs. You
Yep.
get like multi-step downs. You get like uh, how do you call this? Draw lines so that if the part is unusually shaped, it doesn't lock into the part, and the whole thing is machinable. So there's a few extra layers in there, but still not that hard.
Yeah. Yeah. What's next? Like, you've kind of already solved this problem in a way, right? You've got this cloud, you've got a cam assist product. It's got all these features that are super useful to anybody doing any kind of machining. What's coming in the future aside from like improving the product and getting you instead of 80% there, 85% there? I don't know. Like what's next?
And it's like 85% with faster cycle times,
Yeah.
85% off more complex geometries. Like right now, it's not good at mold and die. It would be really nice if it were good at mold and die. It's not
Yeah.
an awful time for us. It's like months in order to build something like that, but there's a really long list. Some of the bigger things that we would love to do are particularly mill turn. I expect that we'll go to mill turn before we go to lathes. Like that's scoped up, it's costed, it's just waiting in the backlog at this point. What else would I really love to do? Like, I'd love to do more around like automatic estimation, but it's not something that's being worked on right now. And I would really love to do much more in-process inspection and post-process inspection as well.
Mhm.
I'd like that to be part of the 80% of the done. It's like, here's the component, but also it's verified. And, it's cut,
Yeah.
check, cut. That's something that we had in Cam Assist 1 that will be coming back to Cam Assist 2 fairly soon. And we're just going to keep on. Like, I would like to be able to do this for any metal geometry. Doesn't matter if it's minuscule or extremely large, if it's got warping going on, or like heat considerations and chip buildup on something very small. No matter what it is, we'd like to have the same product promise. It's not quite true today. We're just going to keep on making it true.
I mean, you kind of already answered this in a way because your customer was you for so long, and I guess like still is, right? But
Nice
the
having a
you
factory.
yeah, yeah. And like the UX, it really shows through in the UX design, I gotta say, like just from having used it, because it feels so natural. If you're used to, if you're used to doing CNC machining, it's everything that needs to be there and nothing that doesn't. And like,
Yeah, I'm really glad you said that because we couldn't do the UX design we wanted for many years because we were building within the CAM package. So all of the buttons and the UI that CAM package has, that was what we were constrained by. Now we're not anymore. Now we can build whatever interface we like. We can put anything in it or almost nothing in it, as you've noticed.
yeah,
Uh, then we can build a flow for CAM that looks the way that we think it should be. So I'm glad you liked it. We spent a long
yeah.
time trying to figure that out and a long time being really frustrated that we couldn't build what we wanted.
Funny story. The beginning of industrial design was it came out of World War II. There were these pilots. They were, American pilots flying I don't know, like what bigger aircraft, I think it was, right?
Like
And
B-24s or something.
yeah, something like that. And they were having crashes, like they would just come back to the runway and crash into it. And they couldn't figure out exactly what was happening. And then they realized that they were changing the controls, right? So the lever for
Oh,
the locations of things and like the
yeah.
way they were controlled. So here's okay, we got better landing gear now, right? So it actually makes more sense for the cable to go on this side of the fuselage instead of this side. So let's put the landing gear, lever here. And then
Yeah.
the guy was used to it being on the left. So he
And then
went to
there's no
reach
space
for
for
it
the
and
flaps on that side. So they put the flaps over on that side, and you're like, landing it, oh, flaps, bang.
yep. exactly. So
Ouch.
like the guy's reaching for a lever that's not there, and then boom, there you go. And he's been up, been flying for 12 hours straight or something like that, and like, hasn't yeah. So anyway, the that was the beginning of industrial design, because then people started coming in and saying, oh, we have to think of the human element of this too, right? Like you can't change the locations of those controls. When you're in a stressful situation, it's got to be muscle memory, right?
Mm.
And yeah, I think it shows through in your UX there for sure. It's like this is a straightforward way. I understand what's happening here. Especially it's good for me too, because I'm a little rusty with this stuff. Like I haven't machined anything in like it's been like a year and a half. So every time I go back to it, I'm like, okay, here we go again. What do I do first?
You got the tarmac right behind you. There's your opportunity.
I know, yeah, yeah. It's we do this factory experience thing at Autodesk
Yeah, I know
University.
the
We
one.
do, yeah. So like I think the last time I was prototyping was the keypad thing we did, but yeah, I don't know. I got to be honest with you, man. Now that I've got this 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 Cam Assist thing to play around with, I think I might be doing a little more prototyping myself now. Um, yeah, let's get into your shop. I want to know where are you kicking where are you tooling around to figure this stuff out?
So we've had a shop about half an hour outside of London for, oh, it must be like 6 years now. I've had it for a long time. Yeah, 2018, 7 years. And yeah, it's pretty big. How many machines? It's probably got about 15 machines running in there at the moment. It used to have more. 15 employees working there. It does quite a high mix. Like we do a lot of work for BAE Systems. We do some really big, like multi-million dollar contracts that run through there, and also some high mix. Like historically, it used to be closer to prototyping, and the longer we've run it, the more we've trended towards either very, very high volumes, which have massive complexities that I never would have imagined. Like it took nearly like 2 years from the first time I heard word of this multi-million dollar contract to actually running continuously off all of the machines that we bought in order to run that thing. Very frustrating. And then lots of aerospace and defense work.
Yeah, cool. So it's still a fully functioning shop where you're taking orders and like,
Oh yeah, we're still going. Like we're
yeah,
still going. We take orders, we do work, but also we do research and development there, and we do video
yeah,
production as well. Yeah, it's a really
yeah,
cool thing. So like, we have a slow motion camera in there that we just got, like a really serious slow motion camera.
yeah,
And I've been watching some of the footage coming out of that. Like you can see chips coming off stainless steel, and they come out of the cut, and they're still silver.
yeah,
But by the time they've moved an inch away from the edge of the workpiece, they've gone bronze or blue.
yeah.
I didn't know that it took that long. I thought that they would have gone that color whilst they were actually being carved out of the workpiece, but it takes like a few milliseconds for that. What's the effect? It's not like annealing when the color of stainless steel changes. No, never mind. Someone will
Yeah.
tell me.
Yeah. Hopefully tell us in the comments. What is that
What is that
effect
process
called?
called? I can't remember. And you can tell how hot the cut was depending on the color that the chip has gone, like between 300 and 600 degrees.
That's really fascinating though, because so like you said, R&D, that's obviously happening there, but do you consider production as part of your R&D?
Yeah, I mean, it teaches us how to cut metal. It's not really, if it's not being made commercially cost effectively for a customer, is it really R&D?
Yeah.
If you made the part but it cost 4 times more than what the market was prepared to pay for it, does your AI really work? I would
Yeah.
argue absolutely not. If it has to be real. That's why the factory exists. It's why it's a factory, not a lab. It's got to be real.
So tell us which machines you have in your shop. Can you just kind of run down a list?
Yeah, sure. So we've got the first one we ever got was a Haspi F2. And then we bought a couple of Mazaks. So we got, in fact, we sold those recently, but until very recently, we had an i500 and a J600, both 5 axis running. Then we got some DMG Mori 60 Evos, which are still in there with automation. Then we got DMG Mori DMU 95s. Those are really useful machines because very few people in the market have a 5 axis machine that is that big, but it's still like reasonably affordable. And so you can, like, you're in a space that doesn't have as much competition for objects that like a meter wide.
Yeah.
And then like a DM 125, some NLX lathes, got a Citizen lathe in there, got a DN Solutions vertical borer, which sometimes does some interesting work for oil and gas. Or what am I missing? And a couple of horizontals. And more recently, we've got a NTX mill turn in there, which I will admit we do not use as much as we would like, because
Yeah.
of the skills gap. but it's really hard to find people who know how to run those things. And so sure enough, it's something that's on our roadmap. Oh, am I missing anything? Yeah, there's a couple of large. Oh yeah, I've got some robo drills and one really large 3-axis flatbed.
Yeah, and you said aerospace is that kind of your larger customer base?
Yeah, it is at the moment. I mean, we've done a bit of everything. So we do quite a lot of automotive testing equipment.
Yep.
Defense aerospace, particularly, the margins are much higher in defense
Yeah.
aerospace. And something that I like, something I believe in, like in building a workshop, is like the you will have the best time if you go and try and compete in a smaller arena. Like,
Sure.
how do you make the arena smaller? You do something that's much more difficult. What are difficult things? Go into nuclear, for example. There is so much paperwork that you might have to hire somebody just to do the paperwork
Yep.
all day, every single day, and it will take a few years to get the certifications. Certification is a really good way to enter a smaller arena that fewer people are playing with. Not very many people can bid on those jobs, but if you're bidding on widgets that anybody in a shed can make, then anybody in a shed can make them.
Yeah.
And then you're competing with literally everyone in your country and probably out of your country as well. So,
Yeah.
there you go. And especially if you're then competing with overseas, you're just going to come under so much pricing pressure. So, like, the question is, can you get into like an industry that has restrictions on it that mean that you are one of a smaller number of companies looking to service that work? Going up in complexity, that's another way. Going into more exotic materials that fewer people can do, that's another way. But yeah, I would try and avoid just being like the 3-axis aluminium milling shop. There's too many of those.
Man, great advice, dude. Very, very useful. I think our audience is going to get a lot out of this one, man, for sure.
I hope
I
so. I
think
mean, they probably know all this already.
I don't know. I mean, there's a lot of young people that are kind of getting started out that are they're interested in this stuff, kind of trying to figure out what their future is going to look like. So yeah, this is
Yeah.
this is a good one, man. Really interesting stuff. What would you be doing if you weren't doing this? Let's say you don't have CloudNC, maybe you've sold CloudNC and you're just doing what it is you want to do. What would that be?
Oh, that's a really hard question. It's almost unknowable because my plan, if I were to do that, would be to sit and do nothing until I discover what I want to do and what I have energy to do, which is a little bit like how CloudNC got founded. I didn't know what I wanted to do leaving college, and I just basically sat doing nothing until the idea turned up, and then I decided that was the one. But I definitely spend more time, building my home, making stuff again. Whilst we've been talking, I've been thinking about buying a 3D printer, sticking it in the corner, and making some parts in this new place, to like hold webcams in various places. I think I would do some getting back to my roots, and then just see what comes next. Probably like a really unexpected, surprising industry, to be like a complete about turn. Still very likely to do with making things, like something that's very much in the physical world and quite interactive. I'm a little tired of sitting in front of my screen. I'd like to spend more time actually like really in front of people. I got a lot of energy from that.
All right, Theo, thanks for coming, man. This is a really inspiring story, and I'm sure our audience is going to love it. Can you tell us where we should look for you and your products?
Yeah, absolutely, Jonathan. It's been great being on ShopTalk. And if you're interested in CAM Assist, as hopefully everybody is, just go to cloudnc.com and you'll be able to fill out a form and our team will be right in touch. Demos everywhere. We think you'll love it.
Awesome. Thanks, man.
Pleasure.
Hey, everyone. Don't forget to like, comment, and subscribe to our YouTube channel to stay up to date with all things ShopTalk. If you're ready to try Fusion for yourself, find the link in our description.